Hi class, let's take a look at this problem here. We have a difference of two proportions. In the problem, note that they tell you that they want to test the claim that the two different proportions are statistically different. So therefore, that means the alternative is going to be not equal to, which is a two-tail test. And now what I need to do is use StatCrunch to find the test statistic and the p-value. So go to stat, proportion stat to sample with summary. Since they are able to give me the information here, they tell me that out of 38, out of 43, 38 were successful. And then for the placebo group, it was 78 and 93. The alternative and null are set up just by the default values here. So just set this up here and then go ahead and hit compute. And right here is my p-value and my test statistic, my z-stat, and the p-value is reported right here, 0.4907. So to 3 decimal places, that's going to be 0.491. Let's check that out. And now it's time to make my decision. Notice that alpha is 0.05. The p-value is substantially larger than the alpha. Therefore, I'm going to fail to reject the null. The p-value is greater than the significance level of alpha, so I'm going to fail to reject the null. There is not sufficient evidence to support the claim that the treatment has an effect. Okay, now they want me to find the confidence interval. Recognize that the hypothesis test here is a two-tail test. Okay, confidence intervals by definition are always two-tail tests. So I do not need to make the adjustment or an adjustment on alpha to find the corresponding confidence interval, because the number of tails between the hypothesis test and the confidence interval are the same. So go back to proportion to sample with summary, re-enter the values again, which is kind of a pain, but unfortunately we have no choice. We have to do this, 78 and 93. And now I'm going to do a confidence interval, and specifically I'm going to do a 95% confidence interval. So go ahead and leave this as the default value, hit compute, and here is the answer here, and I get negative 0.765. So that's going to be 0.77, negative 0.77 to 3 decimal places, and the upper limit is going to be 167.167 to 3 decimal places, 0.167. Note that the difference in the two proportions includes a value of 0, so it goes from negative to positive. Therefore, 0 is within this range. Okay, and that being the case, okay, we know that this result here aligns with the result from my hypothesis test study. Because the confidence interval does include 0, there does not appear to be a significant difference between the two proportions. There is not evidence to support the claim that the treatment has an effect. So in essence, whether I'm doing a confidence interval or whether I'm doing a hypothesis test, I'm going to get the same result, or I should get the same result regardless of whichever approach I take. So based on these results, does it appear that the does Encana appear to have an effect on the infection rate? Well, again, we're talking about an effect here, I would say that the best thing we can say here, conservatively speaking, is that this is inconclusive. So let's try that, and it looks like it didn't like that answer. So therefore, I'm going to probably say does not appear to have a significant effect, would be my next best choice, and that's because of the fact that the proportions did not change. But I would probably want to lean more toward the inconclusive, simply because of the fact it's more of a conservative response. But the answer to the question is going to be B. Thank you.